Okay, welcome. So I'm Ryan. I'm hosting this interview this afternoon, which I feel very privileged to do. So thank you for your time. So my business, obviously the Topham Group, we're highlighting some really important things that are going on in the business world, in the community, etc. And Liz, once you and I had spoken, I felt like it was really important that this was a cause that I know a lot of people will resonate with. I was saying a little bit earlier that it's one of those causes that if you haven't experienced it already, the chances are at some point in your life, either your own family or someone you're connected to will experience the things that we're going to be discussing. And so I thought it was a great opportunity to shed some light on what you guys are doing. So I'll throw it over to you, Liz, maybe first. Talk us through who you are and where you're working and what's going on, and then we'll go to Wai Chen after.
Well, thank you very much, Ryan, for the opportunity. It was a pleasure to meet with you and first tell you about our story. My name is Liz Ferentinos. I'm the co-founder and CEO for Meizon Innovation. Meizon Innovation, we have two treatments that are coming through. One of them is DL33 for dementia, including Niemann-Pick type C, which is a type of childhood dementia, which most people haven't even heard of and didn't even think that it exists. And the other one as well is our treatment MO8 for autism spectrum disorder.
Okay. Wai Chen?
Thank you for giving us this opportunity to share our story. So, yes, my name is Wai Chen. I'm originally from Singapore. So I got scholarship to come and study at University of Melbourne to do my PhD. Then, after I became an independent scientist, I decided to start researching of the effects of hormones and fat in our brains, because I think the brains is the last frontier for biological research. So then, so I'm the inventor and the CSO of Meizon Innovations. 20 years ago, I was thinking about understanding the effect of hormones in the brain. So I decided to look at a disease that have a very strong sex bias. So when I looked around, because I think that by looking at the disease that have very strong sex bias, I can understand the function of hormones better. So autism is the one that stands out. So there are 5 boys affected to 1 girl. So I wanted to understand that, when you look at boys and girls, is it testosterone? So boys have too much testosterone, so that's why they behave the way they are. So,
In general?
in general. So then I start to read up on autism. And surprisingly, when you look at the prevalence means number of cases per 10,000 people of autism, and there is an exponential increase. So if you look at the graph, you go Google graph, and then start from 1950s. So autism first started has a name in 1940s. So the CDC, Center for Disease Control in America, they will record all these diagnoses. Then so it starts from 1950s, it's rather flat. Then suddenly at around 180, it took off like a rocket, exponential increase. Then I thought, what is going on? Why suddenly there's in 1980 there's a... So I went to Google some more. I'm very good at Googling.
Good.
and around 1975, a very popular soft drink company, actually I was told not to say the name, decide to bottle their soft drinks, their drinks in plastic bottles. Yeah. So then I thought, so is it an environmental effect that caused the autism cases to increase? So I started a very simple experiment. I bought some plastic powder and mixed it with agar jelly and raspberry flavored agar, because we actually tested what flavor the mouse would like. And at first we thought cheese and chocolate, but it's not. Only cartoon mouse like cheese and chocolate.
We've been lied to our whole lives. Yeah.
So it's actually fruit. So we put a raspberry cordial, and the mouse will eat it. You give it to them, and they'll hold it and eat it like watermelon. They actually enjoyed it. So we have pregnant mice, and one group will be just the jelly without the plastic contamination, and the other group has the plastic contamination. So they what happened in the midterm pregnancy. So actually, we tested all the 3 terms, and then we found that if the pregnant mouse mom, had the plastic contaminated agar during the midterm pregnancy, their babies will have autism. All the boys will have autism. So you ask me, how do I know the mice have autism? So we actually, there's a standard testing for autism. You put the mouse to a stranger mouse, and then we have video recording and see how often they go and visit the stranger mouse. We put the stranger mouse behind a cage, like a jail. So you will go and visit the jail, and then they will have an empty jail on the other side and see what is the amount of time they spend investigating the empty jail and the jail with the mouse.
Yeah.
So the girls were fine, but the boys, the one that were exposed to plastic, they will have no extra interest in investigating the jail with the mouse. So they will investigate the empty jail as much as the jail that has the mouse.
Okay.
While else the normal mouse will zoom in and look at the stranger mouse, because mouse is actually very social.
Okay.
So that's why if you find one mouse in your house, most likely there are 20. Because they live in groups. So then, yeah. So then, okay. So what's happening with this plastic? So did more and more experiment. In total, we conducted 38 experiments and showed that the plastic actually goes through the placenta, goes into the brain, baby's brain, and switch off a gene that will make brain estrogen.
Okay.
So the brain estrogen is required to make the brain cells connect and makes the brains develop properly.
Mm-hmm.
So for girls, at least there's alternative source of estrogen from the ovary. For the boys, there's no alternative source of estrogen, they have testes. So if they were exposed to the plastic, this brain estrogen gene will be switched off, and then they'll have problem.
Wow.
And that's why the autism is also a spectrum. So it all depends on how much plastic has been consumed by the mom, and then how tight is that gene switch off, just like a leaky tap, so you get a free flowing tap, and then you can so that's why it's a spectrum. Then, and also, of course, there is let's say 5 boys to 1 girl. So of course autism is also genetics, but I believe it's the minority. So the majority is related to exposure to pollutant such as plastic, and also we have now trying to publish another paper that other type of pollutants actually will go and switch off the same gene at the brain estrogen gene.
And is it specifically during the pregnancy period?
Yes, during pregnancy period. Then, good thing is after you understand the mechanism of what causes autism, they can find a way to reverse it, to fix it, right? So I realized that without brain estrogen, that is the root cause of autism. So I go and search for a molecule that the brain can recognize as the brain estrogen. Because you can't just give estrogen to a boy, because that would familiarize the boy into string the testes and develop. So you don't want that. So you can't give just estrogen to the boy.
Yeah.
So then, so we found MO8 that the brain will actually recognize as a brain estrogen, and the rest of the body will not recognize it. Yeah. So now we are actually developing the drug. We are conducting. We actually talked to FDA. So we spoke to the FDA to present our data.
Mm-hmm.
FDA is the Food and Drug Administration of America, where most other countries will look to whether this drug is safe or not. Then usually the FDA will not meet the people, the scientists or the company. They will just respond and email, whether you can start a clinical trial and all that stuff. But they actually wanted to meet us.
Wow.
So we were, is that a really good thing or a really bad thing?
Well, how well known, just to hold the rest of that thought, how well known is this unique that you've discovered this is not...
It's very unique.
Yeah.
So unique that we made to the front page of the Australian on the 8th of August, 2024.
Wow.
Yeah, it was on every single news channel
Okay.
interview. Yeah. So the whole discovery is really it's a
Very
breakthrough.
unique.
Yeah, very unique. It's a breakthrough.
I think you sent me the Channel 7.
Breakthrough.
Yeah.
Yeah.
So yes, and also that's why we got accepted. The data was accepted in the one of the highest ranking journal, Nature Communications, which only published 7% of the manuscripts they received.
That's amazing.
Yeah. So and also the whole thing is not just the cost, plastic increase the risk of autism. It's not just all mouse work. So we also did the human study. So what we did was 10 years ago, my collaborator, Professor Ponsonby, and Louise Ponsonby, who is our scientific advisor. So she is a clinician and epidemiologist. So she actually and her other collaborators set up a cohort called the Bowen Infant Health Study. Bowen is the hospital in Geelong. And they actually collected the blood and urine from pregnant mom at 36 weeks 10 years ago.
Wow.
So they measured all the different things in their blood urine, including plastics. So then we waited for 10 years and contacted the moms again and asked them what happened to their children. Then not all 3,000 replied. 1,074 replied and told us what happened. Took the survey. The rest might have moved house or lost interest. Yeah. And then we predicted from the prevalence, 11 boys will be diagnosed with autism and ED.
Wow.
That happened. And more amazingly is the boys, all their moms had more than medium level of BPA. No boys was diagnosed with autism if their mom had less than medium level of BPA. So that's the study that support our mouse.
It must be exciting to see, because obviously this journey has been going for a while now.
Yeah.
And
20 years.
Kind of, 20 years.
Yeah. So 10 years to do the mouse experiment. And then took me another 10 years to wait for took us another 10 years for the children to grow up. Yeah. So
we'll stay with the autism for now before we move on to the dementia.
Yeah.
But so what's happening now? So where are we up to now?
So now we are so when we met FDA, they said that so 28 of them show up.
28 of them.
28 of them show up.
What happened to the other two?
Mind blowing.
Yeah.
We were all ecstatic.
There was 6 of us.
Yeah.
And then I was really scared because why so many show up? I thought they're going to tell us off. But actually not. The chairperson was really, really enthusiastic and friendly and said that they wanted us to congratulate us because we are the first company that tried to test the toxicity of a molecule not using animals. Yeah. So what we did was that we actually, because I actually don't like to experiment on animals. I try to not use animals. Actually, I used to be vegan. so I try not to.
So did I.
Yeah.
You get held against me all the time.
Are you still?
Vegetarian.
Okay.
Yeah, I try to choose vegetarian, I think, because my husband said that if I were vegetarian, he won't marry me. You can cut it off. So yeah, I don't eat red meat that much.
Okay.
Then, so let's come back. So
yes.
I digress. You can edit that out.
Staying. The whole section is staying.
So anyway, so I and also Joe Biden in January, the U.S. president, January last year actually signed a bill and said that FDA cannot request for animal study and try to reduce animal study. So the traditional animal study toxicology is that they feed the mouse or the rat or rabbits or dogs every day the drug and for 1 week or 1 month or 6 months or 12 months to see whether they develop any side effects. So instead of doing that, we actually hired this company in Boston called Emulate, which is the same company that FDA used to test the COVID vaccine.
Okay.
Because COVID, was serious and they needed the testing really quickly.
Yep.
So this company Emulate can actually grow organ in the chip.
Okay.
Yeah. So they have human liver, tissues
Wow.
in the chip, and then human kidney tissues in the chip. So they can flush the substance
Yes.
to the chip and then observe whether the tissues actually die. So it can get quite quick. So in 10 days, you can
Yes.
tell whether the liver has died or not.
Okay.
Yeah. So that's why we actually visited them. And I was lucky that I was studying at Harvard at that time as well. So it was just a Uber drive.
Like, did they bring you to the right place? Like, you bring the wrong place.
What is that? The same thing. So
just timeline wise, just keep so. When did you meet with the FDA?
Last year, 24th of July.
July. Okay,
yeah,
so this
July.
is a year, basically almost a year to the day.
Yes, July. And then so our organ on chip toxicology showed that MO8 is totally safe.
Okay.
Yeah. So that was great. That's why we thought, okay, the human kidney tissues and liver tissues did not show any adverse effect. They didn't die off, these change shape. So we should be able. We want to start our clinical trial in human. So that's why we submitted the application to FDA, and also we managed to make 99.3% pure MO8 large scale. Factory scale. So we have to optimize the synthesis production reaction. So we also presented that to the FDA and also the impurities to the FDA. So FDA actually approved of our production methods and the impurities in there.
Yes.
So they're happy with that.
Yep.
But because this is going to be a chronic treatment, just like people with diabetes, their body cannot produce insulin, so they have to take insulin the rest of their life. So in this case, the autism people, they can't produce the brain estrogen, so that means that they have to take brain these MO8 substitute the rest of their life. So because that means it's a chronic disease. And because it's a chronic disease, FDA usually will require 12 months animal toxicology. But because we produce these organ chip data, they said they will require a 6 months animal toxicology. So this is one part of the money that we need to conduct these 6 months animal toxicology in terms of millions of dollars. Just imagine they have to feed all these dogs and rats every day for 6 months. Then, but at the same time, what happened that the FDA and TGA, which is the Australian equivalent of FDA, the TGA, they will allow you to start phase 1 trial, which is a safety trial in humans, the human healthy volunteer, after just a 1 month animal toxicology.
Okay.
So they have different criteria.
Yes.
Yeah. So that's great. So that means that at the moment we are starting doing the 1 month animal toxicology, which should finish by end of the year. Then we can start our phase 1 trial of MO8 in human in Australia next year, 2025. And then at the same time, we can do the 6 months animal toxicology so that we can get the data that FDA needs. And then we can start the phase 2 trial in America.
Okay.
Yeah. So we are pushing things along.
Yes.
Yeah.
Wow, that's an incredible journey so far. And that's I was going to say half. That's probably not even half. That's the one side.
Yeah.
We've spoken about like the autism side of things, and then there's dementia that you're working on as well.
Yes. Yeah.
So go back to the start with dementia.
Okay, so dementia, yeah. So what happened is like, okay, so I think I've solved autism. Like found the cause of it and then found the molecule that can reverse it. So I thought, okay, let's see what else I can do. So nobody can treat dementia yet, including Alzheimer's disease. I like to explain what's the difference between dementia and Alzheimer's disease.
Yep.
So dementia is the term that describes the condition where people forget stuff, can't learn stuff like cognitive decline. They can't, brain's not working that well. Yeah. Called brain fog. Then Alzheimer's disease is a type of dementia. It's about 60-70% of dementia, where when you do the MRI scan, you will see white patches in the brain. So these white patches are protein that is not functioning anymore. So the protein is called the beta amyloid plaque and also the tau tangle. So what do I mean by denatured? So you crack an egg, you see the egg white, that's pure protein, and it's transparent. But if you denatured it, if you cooked it, applied
That was
heat,
very cute. Sorry.
it turned white.
Yeah.
And then it has been denatured. It's not its original form anymore. Yes. So for a long time, for last 30 years, in fact, when Professor Alzheimer found this plug in the brain, he hypothesized that it's the plug that caused dementia. So everyone around the world, all the scientists, Alzheimer scientists, they have been trying different ways to dissolve this beta amyloid plaque. So much so that they actually discovered a way to do it last year. And the way to do it, Biogen, the company, they actually found antibodies. Everyone knows antibodies. So the antibodies that they can inject into the patients intravenously, and the antibodies will break down these beta amyloid plaque. So they believe that if these beta amyloid plaques remove, patients will become normal again. And I actually watched the debate. So FDA actually, before they approve of a drug, a brand new first in class, first type of this drug, they will actually have a panel of experts. So the expert will be reading all the data to show that whether it will work or not. And then the chairperson, and then they will go around table to vote. So out of these 11 experts, they actually telecast it live on their website.
Okay.
Yeah, it's quite interesting to watch. And
I can't imagine that. Yeah.
So I was watching it live, and then the 10 of them voted no, rejected the job. One neutral. So I thought, okay, they're not going to approve of it. But strangely enough, the next day, FDA approved of it.
Wow.
Exactly. so then the 3 of the experts were so angry, they actually had a media meeting.
Yeah.
And media release, and they resigned because they couldn't believe that FDA actually approved of the drug. Then because of the serious side effect, and also they didn't have data that they will reverse the condition. They only have data that the mice will actually slower their progress. So it's not a treatment. It's just like to slow the progress. Then, sure enough, 12 months later, the report come back, and patients that were given the drug have much higher mortality rate, and they will die compared to one that's not on the drug because of the brain blood bleeding. Tongue twister for me.
Yeah. Well.
And so because of that, bleeding in the brain is serious. Yeah, that's why it's like a stroke. So they actually died, and that drug is not approved by TGA because of 2 things. Because of its cost, so the yearly cost $35,000.
Okay.
And also the serious side effect. So that was not
approved.
Not approved by TGA. So for myself, I came from another angle. Our drug, the DL33, does not go the beta amyloid or tau way. So it's a total paradigm shift, and it's something that I wouldn't have thought of, but I actually discovered it by accident.
Okay.
Yeah. So because that's why it's a paradigm shift, something like, Yeah. It's not an increment of other hypotheses. It's a total accident discovery, just like penicillin.
Yeah.
Nobody know about antibiotics, and then go, when
So how do you accidentally stumble across this?
Yes. So how do I accidentally stumble across this was that I said I decided to maybe I should look into dementia when I completed my autism study. So at that time, 10 years ago, there was a coconut oil craze.
coconut oil.
Yep.
Okay.
I saw the current affairs. There was this GP that actually went on current affairs and said that her husband has dementia. So she asked her husband to draw the clock face that he wanted to draw, and the husband has dementia. I couldn't even draw the clock face. So then, at that time, also at the conference, they said that there is a brain diabetes hypothesis. So what happens is our brain needs glucose to work. The glucose is a source of energy, but the glucose do not diffuse across the blood-brain barrier by itself. It has to be picked up into the brain by a transporter called glucose transporter.
Okay.
So that there's evidence that when a person aged, the level of glucose transporter actually decreased. So the brain is actually starving of energy. There's no glucose. So but our body can convert coconut oil into a substance called ketone bodies.
Mm-hmm.
People who are having a ketone diet, that's
well,
why
when you said 10 years ago with the cocoa, I thought, was that keto?
Yes, exactly, keto. Yeah. Yes, keto. So keto, the ketone bodies, they do not need any transporter. They will just cross the blood-brain barrier. And our brain can actually use ketone bodies to supply them with energy. Yeah, they can burn ketone bodies into energy. So I thought, yeah, that sounds logical, right? But I couldn't find any scientific evidence. All these are hypotheses, theories. Then I thought, okay, let's start an experiment, and then we can test whether that's correct. So I have a cohort of old mice. So the lifespan of mice is 2 years.
Okay.
So we have a batch of mice is about 20 months old. So they are pretty old, human 80 years old. So they have cognitive decline, deficit, so they don't learn as well, because we have all these behavior tests that can check whether the mouse can learn things.
Okay.
And so I usually want the experimenter, the person that's doing the experiment, blinded to the treatment. So the student did the experiment, and then we actually mashed up the oil, the coconut oil, and then we actually have a control oil, with the control oil in mashed with the pellet mouse food. So the mouse food is like dog food,
Okay.
little pellet.
Yeah.
So we actually bought a blender, blend the oil together with food and reshape it in bowl. So we call it oil A and oil B. So we have a control oil, an oil that cannot be converted to ketone body, because I want to test whether it's just any oil will work. Then, so the student did the experiment, and clearly one group, oil A, the mice become very smart, and oil B, the mouse is still, can't learn.
Normal, yeah.
Not normal, like have dementia.
Or it gets worse.
They will
just like,
yeah. At 20 months old, they already have dementia. They already can't learn. Yeah. So then oil A actually reverse. They actually can learn better. And
wow.
and then the ones that were just have no oil, just regular food, didn't learn either. So my student was really happy and think, oh, oil A must be coconut oil. So we actually had a meeting, and she presented her data, and then my research assistant unveiled the identity of the oil. And it wasn't oil A. Oil A didn't work as well as oil A wasn't coconut. So oil A is the one that worked, but did not. It wasn't coconut. So everyone. Then they all turn look at me and say, "This
is such a roller coaster."
I know. So then he said, watching it, they said, turn around and look at me and said, "Watching, you're wrong. Your hypothesis is wrong. Coconut oil didn't work." And then I said, "That can't be wrong. You guys must have messed up. Yeah, you guys must have messed up." Then I said, maybe you write down the oil A and B wrongly, so repeat the whole thing again. And this time I went to the lab and I blended the oil with the mouse food myself and write down really clearly what is what, but they don't know what's A or B when I switch the identity. So did the whole experiment again. I did actually, then oil A is still working. and oil is still not coconut oil.
Wow.
then my student said to me, I need to write out my thesis. Watching, yeah, wrong. So what do I write in my thesis? Then, because I don't know why the other oil worked, right? So I don't know why oil A worked, which is not coconut oil. No idea why it worked. So I said, all right, let's do this. Let's take out the brains and then do an experiment where they can actually separate the more than 700 types of fat in the brain. Our brain is actually the fattiest organ. It contains more than 60% fat.
Okay.
Yeah, so all the fats are really important. That's why it's all there, right? So, but people don't really know what they are doing there. So then I did have a collaboration with the biological science department. So they actually measure the 700 species of the big data analysis, more than 700 on all these different groups of life. And strangely, only one molecule, which we call DL33, not the long scientific name, so we just called it as DL33. So this DL33 is the only molecule that is really low in the mouse that cannot learn, the mice that cannot learn. So in a mouse that can learn, whether it's young mice or the mice that was taken all A, will become very high, and then they can learn. So two things that we discovered here. One is young mouse DL33 brain is very high, and then young as in 3 months old, which is like a teenager, and then at old mice, which is currently human about 18 years old, it actually dropped to almost nothing.
Okay.
Yeah, but then when we gave it oil A, it actually go back up. Then so I googled for 2 days and nobody ever paid attention to oil A or DL33.
Yeah.
Nobody ever paid attention to it. Then I was quite excited, so I went up to our deputy director, and said, "Can I publish this, or do I have to patent this?" Because all these experiments was conducted with fluorine, and then anything discovered under the roof of fluorine, the patent intellectual property belongs to them.
Okay.
So if we discover something brand new, we have to ask whether Florida want to patent it or I can publish it. Actually, I didn't want to patent it. I'm sick of patenting because I patented MO8.
Okay.
It took too long. So I just want to be famous. So I just want to and then everyone can just start taking oil air, right? Then my director say, "What's happening with the human brain?" Then I don't know. I don't have funding to do the human brain. So he said, "I'll give you some funding to do the human." So the human brains, next to fluorine, we actually have a brain bank where people actually donated their brains for research.
Okay.
So there were all these big freezers with brains in that. so
Sounds terrifying. Yeah.
Yeah. I don't know how to tell this story. I want to tell this story. Oh, you can edit.
You've already started. It's still going.
Yeah, so one day that was when I was still a student. I did my PhD at Florida. So when I was still a student, I went into the lift, and then another courier came into the lift as well. And there was a trolley, metal trolley, and on top of the metal trolley, it looks like a watermelon covered with a green cloth. Then I looked at it, and I looked at him, and then he nodded his head. So they literally transported the head to Florida so that they can.
I'm so glad you told me.
So we have to thank people.
You have to thank people.
Yeah, to thank people that actually donate a brain, and they should encourage that they donated a brain so that our science can go forward. So they actually help me with my
scary
study.
Stories. Yeah.
So then, but we have to pay for the samples from them, not because brain bank is making money, but because they actually have to upkeep by all the freezer and all these.
Because they have costs.
Yeah. So it's actually just a cost recovery fees. So I took the brain sample from healthy young male, from Alzheimer old male, and healthy old male, and different part of the brains. They are sent it to the biological sciences school, and then they did the analysis, and then they sent back the graph And then when I look at the graph, I was actually really excited. And I actually called my husband at work. I seldom call my husband at work. And then I said, I think I might win a Nobel Prize.
I hope so.
Then he said, okay. Then I said, I think maybe I have discovered the cause of dementia. It's the deficiency of DL33. Because what we saw in the mice was exactly what we saw in the brains, the human brains.
That is like, it's one of those pinch yourself moments that you can't believe you're saying that as a sentence. Just discovered.
So
essentially what's causing.
And which I say accident. Nobody thought about that. Everyone has been focusing going down the road of the Alzheimer plaque and the tau. So I called a student in, and then I show her the graph of the human brain. I didn't even say anything. I just showed it to her, and then she started crying because she actually can understand the enormity of this. So then I thought, okay, to test whether my hypothesis is correct, the deficiency of DL33 is the cause of dementia. So I can just make some DL33 and feed it to the mouse and see whether they become smart again. Right. So I contacted a drug company and say, can you please make this for me? And then they say, yes, we can make it for you, but it costs like $10,000 for 1 gram.
Wow.
Because they have to, work out how to make it and purify, and then when turn on the machine, minimum, they will charge me $10. So I said, okay, this is $30,000. Can you please, give this up? And indeed, the mouse did become smarter. So they took the DL33. So then I have to approach, because Melbourne Uni is on campus of University of Melbourne. And also my collaborator, the School of Biological Sciences, they are part of University of Melbourne. So the intellectual property also belongs to University of Melbourne, for both Florey and University of Melbourne. So I had to approach the commercialization office of University of Melbourne and say, are you going to patent this? Florey, you like to patent, but you want to patent it as well. So there are many, many researchers at University of Melbourne. So everyone thinks that their stuff, their discovery is worth patenting.
Of course.
And then don't have the budget to patent everyone's discovery. So we had like a mini Shark Tank. So we actually go out to a group of, there's a panel, and then presented my data, and I think I have a bit of baby face at that time. The panel said, you look the youngest, but I think your project is the most important.
Wow.
So they decided to patent it. And then at that time, that's 10 years ago, they will assign an officer to nurture this project. The officer will introduce VC, venture capitalists, entrepreneurs, talk to you. So the director at that time, Carrie Hegarty, she loves the project. So she assigned herself to the project. So I was very lucky. So the director assigned herself to the project. So then that's Liz side of the story.
And that's when Carrie spoke to me. And at that time, I had recently, 4 months before, lost my mum to dementia. And I remember I met with Chin and Carrie in a cafe in the city. Fed Square.
Right.
And Ryan, I was just crying because I was just listening to the story.
I was just sure about the chat.
And I was just crying because I was just like, I can't bring back my mother, but we can help so many millions of people. And if we can just empower, which is what actually Meizon means in the Greek Latin word, empowering one's within, then we can actually change people's lives. And I met Chin, and I was just blown away by the science and being, blessed to be, to help support and facilitate your company and raise the capital. And we just wanted to, help as many people as we can. And so it's more so as well now about trying to be more proactive than reactive. So we can also try to, take control and the blood test alongside with the treatment.
So we can measure the level of DL33 in the blood.
Yeah.
So we have shown that in the Alzheimer mouse or the old mice or in human blood, that the level of DL33 indeed go down when Alzheimer's dementia. Yeah. So that research is actually funded by the Victorian Medical Research Acceleration Fund.
Okay.
So this is another funny story. So on the 18th of March 2020, Dan and Jules were supposed to come and shake my hand, give me a check.
Yeah.
And we were all very excited, clean up the lab, figure out who is going to stand where and organize the breakfast. He's supposed to come in the morning and put on a brand new lab coat with flory, name. Normally, there's no stain, they're brand new ones. And that morning, I think at 8 p.m., and Dan and Jules people contacted the PR, public relations officer, and said, sorry, the trip has been cancelled. They were like, what? So it was a total anticlimax. Then, later, 2 hours later, he announced COVID lockdown. That's why I always remember the date.
Yeah.
Exactly. He announced COVID lockdown. So that's why I remember the date. I don't know whether you realize by now I'm a bit like Sheldon. I remember tiny details, which poor people, because I'm putting all these details because my husband would say, spare me the labor pain, just show me the baby.
And say it like you're Bluey.
But I call her Einstein. I've got Albert Prouman is my co-founder. And I said, I'm so blessed because I've got Albert and Einstein. Albert Einstein's, right? So
it makes sense.
So basically, because we did, I brought that out because that means that our science has been viewed by the panel. Yeah, we haven't published it yet because we don't want to get screwed. So that's why we were using a code name. Yeah, but the science is actually being reviewed in the application. So that's why we were awarded, and he gave out a handful of these grants. That's why he was coming to Florida to congratulate us. Then so then there's another part of the story which is really which I don't know, I get a bit teary talking about it. So what happened was, so going on with DL33, getting trying to work out why it worked, because nobody knew the function of this molecule. Nobody cares about it, right? People didn't think it actually has any function. So I had to work out how it worked. Then Meizon supported the research. Then Liz called me again in the evening, and she was sobbing. I said, Chin, do you know whether DL33 can treat childhood dementia?
That was a term that's stuck with me since you said it.
Yeah.
Heard of it, and it's just stuck.
Yes. Then she said that. Then I said, I don't know anything about childhood dementia. Yeah. Then she told me she saw this program. Which program?
Yeah, so I saw the morning show. Yeah. And what had happened was I was overseas at the time. And a Labour minister had contacted me in Greece and said the federal government want to speak with us because of our treatment with DL33 and the blood test. That morning, when I was getting ready to leave to go meet at her office in Broadmeadows, as I was leaving, there was a story on childhood dementia, specifically called NPC, which is Niemann-Pick type C. I then cried for 1 hour driving from my home all the way to Broadmeadows. And as I walked into her office, I probably had bloodshot eyes. And the very first thing she said to me, she could almost tell, and she said, "You saw what I saw." And I said, "Yes."
What was that?
Oh. No. That's when I turned up at the office at the federal minister, Maria Vavakano. Yeah. So that was Maria Vavakano at the time. And she said to me, will DL33 work? And I said, that's exactly the phone call that I already rang my Chin. And I said, I didn't even know this existed because I lost my mum. But my mum lived a life. She lived till 83 years old. I said, how can this happen that a child can either be born or develop dementia and they haven't even lived their life? And I rang my Chin and I said, Chin, is there a chance that DL33 is a deficiency and these babies just can't make it? And that was my question to her. And I said, where at the Florey, is there someone there that specifically knows childhood dementia, and we can ask the question? And
So I said, I don't know anything about childhood dementia. And I said, I'll ask around. Then, strangely, straight away, it popped up on my LinkedIn about Yahoo.
When the algorithm actually works for you.
He actually put on LinkedIn and said, and she was talking about childhood dementia on the LinkedIn. Then I know Yahoo for 20 years. I've been in Florida. And I know that she has been working on Niemann-Pick type C disease. So I didn't realize that Niemann-Pick type C is also called childhood dementia. So I actually approached her and then I told her about DL33. I said, do you have any? I know she has a mouse model, that's why she's working on it. So Florey has all kind of mouse model. Then she gave me some of her NPC, Niemann-Pick type C disease mouse, and so that I can test whether the DL33 worked. So for the mouse, what happened is that they will actually develop, so in human, they will develop symptoms at 5 years old. So at 5 years old, suddenly they will get lose the mom and dad. So otherwise, at 5 years old, you really check the box, right? So then they're talking, and then eventually they'll become paralyzed. And most the lifespan is about 10 years old. So now,
and I think you mentioned about 100 children.
It's a rare disease. It's a rare disease. It's a mutation.
Yeah.
You have to have both copies of the mutation to get the disease. So what is the disease? So what happened was they have a mutation in the cholesterol transporter, type of cholesterol transporter. So because they don't have the cholesterol transporter, so the cholesterol is trapped in the cells. And then they will have more and more of the cholesterol. Eventually, the cell will actually die. So that's why it happened. Then now there are treatments, FDA-approved treatments for the Niemann-Pick, which can actually make the cholesterol leak down the cells. So they can actually improve the lifespan now. So that's the drug started 20 years ago.
Yeah.
So the children that are on the drug, they are actually 30-odd years old now.
Wow.
But the problem is the drug cannot reverse their brain function.
Yeah.
Yeah. So they are actually maintained alive in ICU as a vegetable.
Yeah.
But the parents actually keep them alive because hoping that they will have another new drug that can reverse their function. Yeah. So when I heard about the childhood dementia, which is 10% of childhood dementia caused by Niemann-Pick type C, and a very old memory floated in my head, surfaced in my head like a balloon. So what happened was, when I was an undergrad in National University of Singapore, we do study a lot of genetic disease that have disruption in their biochemical pathway. Yeah. So Niemann-Pick type C disease stuck in my head. They actually can't make DL33. But a lot of people are not paying attention to that because they think that the cause of the death is because of accumulation of cholesterol.
Yeah. So
I asked Yahoo to give me the mouse so then I can start breeding the mouse. And then I asked them to send out the mouse. And when the mouse is about 3 weeks old. So at 3 weeks old, they can be living independently. Okay. So they can eat solid food. So at 3 weeks old, send out for me to test the drug. So at Florey, we actually split the research area for the mouse level. One side is the research area, the other side is the breeding area. So in the breeding area, we can't go in there. Only the staff can go. So I know on a Monday, 5 mutant mouse coming out. Didn't come out. So I emailed them. What happened to these 5 mutant mouse? They said, they look so sick. That's why we killed it. We culled it for humanity because we don't want to let them suffer. Yeah. Got animal ethics committee approval to reverse to test our drug to see whether the mouse will be alive. Because usually when the mouse gets sick, it will count it so that they're told. So I said, please send them out, don't count it.
Yeah.
Then they sent one out, the baby boy. And I wasn't at Florida because I didn't work part time. Then Chris, my research assistant, she actually took a WhatsApp picture and then sent me. He said, watching the mouse look really sick. I don't think it'll survive more than 24 hours. It's very cold. It's lying on the side. Because, the mouse running around, his brothers, 4 other brothers running around, and then he was lying on the side. Then I said, just give it the DL33. We actually resuspended the DL33 in strawberry milk. So I said, mouse like
Berries.
fruit, berries. Yeah. So I said, just dribble it, into his mouth with the syringe. Then I was very busy with something and I forgot about it. And we had to dose the mouse every single day because mouse don't do Saturday and Sunday. So I'm the one that do the Saturday and Sunday shift. So that my staff and student can have a rest because then I'll live closest to Florida. So I went in. So Wednesday come out, so I went in on Saturday, and then I opened the box of mice. And then everyone's running around, really active. Oh no, the sick mouse has died. So I called Chrissy on the Saturday. Chrissy, what happened to mouse 182? I remember what happened to mouse 182? Did it die? He said, no, recover the next day.
Amazing.
It was amazing. So he said, oh, I forgot to send you this picture. So he took a picture the next day and the mouse was standing upright, pushing, they call it pushing tail, one eye, totally healthy like his brother.
Yeah.
Yeah. So then other mouse came and we managed to reverse them. They can, so one of the symptoms is the weakness in the muscle. So we, of the human. So we tested out in the mouse. So in the mutant mouse that was on placebo, that was just strawberry milk with no DL33. They did have very weak grip strength.
Yeah.
Yeah. So with the one that actually had the DL33 for a couple of weeks, they actually restored their grip strength almost like the healthy normal mouse.
Yeah.
Yeah. And then with the most amazingly is when we take out the brain, the sick mouse, the main like chocolate mousse. Then normal brain should be like tofu.
Okay.
Yeah, so you actually become tofu, but we actually measure the brain activity. So normal mouse brain activity is about 155, and then the sick mouse is about 135, 140, and then that's on placebo, untreated sick mouse. And the one that is on DL33 went back to totally normal. So this is the first treatment that I know. Other treatment, they would say that all the mouse have less cholesterol and strength. Yeah. Nobody say that their brain activity became normal.
Yeah.
So we are the first one.
Effects.
Yeah, we totally and we are able to double the lifespan of the mice. So usually we will have to count them by 7 weeks, even if we feed them with the milk. And we actually double it to 14 weeks. And yeah, so
yeah, so safe to say you guys are doing some pretty incredible stuff. And we're conscious of time, so we've got to close up. But how do people get involved? Like, what do you guys need at the moment? Because there'll be people who want to help and want to kind of follow the journey. Put the links and that kind of stuff so they can get in touch with you. But what do you guys need at the moment?
Yeah, I must say that the science, I'm very confident of the science. What is the main risk is money.
Yeah.
Yeah, so phase 1 trial is really expensive. The toxicology is all in terms of millions of dollars. So we would really like to push forward for the 6 months toxicology that we need, because it's going to be a long-term chronic treatment again.
Yeah.
Yeah, because due to mutation, whether you have an Alzheimer gene or the Niemann-Pick gene, and old age, we don't make the patient will not make enough DL33.
Yeah.
That's why now they need to take the DL33 in tablet form and just take it to replenish it, just like if you don't have enough vitamin D, you take a blood test, vitamin deficient, pop the pill, then it's fine. So our long-term vision will be you can go and take a blood test and see whether the DL33 is low, and then you just take the pill, and then that might prevent you even developing dementia. Okay. You don't have to wait till you have dementia reverse. Yeah. But before all this can happen is the investment of the fundraising.
Correct.
Yeah.
But we have also been, which is really, really important, Ryan, for people to know, is that we have been granted orphan drug designation and rare pediatric drug designation from the US FDA.
Okay.
So that is a fast track pathway.
Yeah, we can fast track pathway. So that actually help us, because normally in phase 1, it's just healthy volunteer.
Yeah.
Yeah. So that, but because with the rare orphan drug designation, we can actually include patients in our phase 1 trial. So we have phase 1A healthy volunteer, and if there's no any side effect, we can actually recruit patients in phase 1B.
Okay.
And also the other bonus is that we can apply for expedite review, because the FDA might take up to 2 years to read your stuff. But then with the designation, we can actually, FDA will have to give us the answer in 4 months.
That's excellent.
Yeah, so all these helped. Yeah, so that's why I think we have a good planned out path.
Yeah.
Have everything in Chinese, everything is ready except the right wing, the sailboat, yacht, explore the world.
Yeah.
So now the wing that we need is the funding, the investment. Yeah.
So we'll obviously continue to share your message and what you guys are doing. Obviously, it's an incredible work that you guys are doing, and well done so far. And thank you for coming and spending some time and explaining and sharing it with the world.
Thank you.
Thank you.